In this screencast, we're going to talk about electrical systems, in particular, Kirchhoff's laws. So, the idea behind an electrical system is you have a battery. Say it's a 12-volt battery that you've got in your car. When the battery starts emitting, it starts sending electrons throughout the system. So the idea is the electrons start flowing. Well, when they get to this node, the electrons have to split. Some of them flow that way, some of them flow that way. Well, as the electricity moves through the wire, it encounters resistance, something to prevent its flow. Ohm discovered that the voltage drop due to a resistor is you take the voltage, take the resistance, times it by the current. So if you take a resistance times a current, you get the amount of voltage used or eaten up by a resistor. You can think of a resistor as a light bulb, you can think of it as a computer. It's something that's eating up or using the electricity. So electricity starts flowing, it hits this node, and then it goes along. Kirchhoff noticed that if you have a current, I need to give some names to these things. First, before we get there, we need some resistance. So resistance normally is given in terms of ohms. What is an ohm? It's a measure of the strength of the resistance. We'll say that one has resistance 1, I'll call that R1, we'll call this R2, and let's say it has resistance 3. And let's let R3 have resistance 6. The currents, as they move through, the current along this entire wire will always be the same, so I'll call the current there I1. On this wire, I'll call the current I2, and on this wire, I'll call the current I3. In the problem, we've got batteries, and we have resistors with known resistances. The only question is, what are the currents through this system? And Kirchhoff discovered how to get equations to help us find the currents. So the ideas are, at a node, when current flows in, it has to flow out. The same amount going in has to flow out. So, at nodes, current in equals current out. Well, there's two nodes in the picture. So at this node, there's I1 is flowing in, and we have I2 and I3 are flowing out. At this node down here, we have I2 is flowing in. Also, I3 is flowing in, but what's flowing out is this current I1. These two equations are the same, so I'm just going to ignore the bottom one, and we'll only use that first one. So this is for Kirchhoff's first law, current in equals current out. The second law is that voltage supplied equals voltage repressed on loops. Voltage supplied is voltage repressed on loops. What? Well, batteries supply voltage. This is supplying a 12 volts to the system. Every time you encounter a resistance, voltage is dropped based on what the current is, or what the resistance is times the current. So, as I go around a loop, this first loop, this interior loop on the left, I have a 12 volt being supplied. As I move along the loop, I encounter resistance right here with this resistor, and its current is I2, the resistance is R3, so I take the resistance, which is 3, times it by the current, which is 2, and that gives me what happens on this first loop. Now I keep on going, and I encounter on this same exact loop another resistor. This time, the voltage is, or the resistance is 1, and the current is I1. So that right there is our voltage supplied equals voltage repressed. Now we look at another loop. On this loop, we have no batteries, so there's no voltage supplied. Now, as I move along the loop, I could start here and move around. As I move along I3, I encounter a resistor with 6 ohms, so I have a 6 I3. I keep on moving along. And as I move along, I encounter another resistor. But notice I'm flowing up as I move around this loop. I'm going up when I2 says go down. Well, that says let's change the sign to a negative because I'm going opposite the current. And I hit the resistor where 3 is the resistance and I2 is the current. I currently have 3 equations. Well, this first equation I could write as I1 minus I2 minus I3 is 0. The second equation I could write as 1I1 plus 3I2 equals 12. And this last one I can write as minus 3i2 plus 6i3 is 0. Well, that becomes a matrix. 1, minus 1, 1, 0. 1, 3, 0, 12, 0, minus 3, 6, 0. If I reduce this thing and find the reduced row echelon form, out pops the following matrix. You can do the calculations on the computer. We get a 4, an 8/3, and a 4/3. This is our current in the first, this is our current in the second, and this is our current in the third. Again, now we see here is an example of where reduced row echelon form yields a solution to a physical real-world problem. And that completes the screencast.